In previous chapters, we've discussed how bond formation actually has stabilizing effects. So it makes sense that in order to break a bond, it will require energy. The amount of energy is called bond dissociation energy, and it's represented by the letter D. And this is the energy required to break a mole of covalent bonds in gaseous species. There are a couple of trends in bond strength that we can discuss. The first says that bond strength tends to increase with an increasing difference of electronegativity in the atoms involved in the bond. Here we're going to be able to closely see this by showing a series of bonds where one of the atoms is the same and the other atom is changing. This means that the electronegativity of hydrogen is being held constant while the electronegativity of the corresponding halogen is being changed. And remember, the periodic trend for electronegativity says that it increases as we go up. So fluorine is more electronegative than chlorine, then bromine, then iodine. And correspondingly, the largest difference in electronegativity between hydrogen and the halogen is going to occur with HF, and the lowest difference is going to occur with HI. And you can see that there is a corresponding increase in the bond dissociation energy. HF, which has the largest difference in electronegativity of the two atoms involved in the bond, has the highest dissociation energy, and HI, the one with the smallest difference of electronegativity of the atoms involved in the bond, has the lowest dissociation energy. Another trend says that bond strength increases with the bond order for bonds between the same two atoms. So here we have two carbons that are bonded together, and we're increasing the number of bonds between them, and that's what we mean by bond order. A single bond has a bond order of 1, double bond has a bond order of 2, and a triple bond has a bond order of 3. As the number of bonds increases, there is a corresponding increase in the bond dissociation energy. So the CC bond has the smallest bond dissociation energy, while the carbon-carbon triple bond has the largest bond dissociation energy. We can see the same trend in a carbon-oxygen bond. Here, a carbon-oxygen single bond is weaker or has a lower bond dissociation energy than a carbon-oxygen double bond.